Welcome to the lecture 2 of Topological Dynamics एंड यहाँ पे आज हम जो हमारा लेक्चर 1 का कॉन्सेप्ट था टोपोलॉजिकल कॉन्जुगेसी उसे हम कंटिन्यू करेंगे ओके नाउ फर्स्ट लेट मी रिकॉल or give you a recap of what we have studied in lecture 1. सो लेक्चर 1 में मैंने आपको बताया था कि एक topological dynamical system is basically this pair xf where x is topological space and f is a self continuous map right. फिर मैंने आपको एक definition दी थी. We discussed fix f, periodic f, and further we discussed what do we mean by two spaces to be topologically conjugate to each other. तो मैंने आपको बताया था two spaces xf yg they are said to be topologically conjugate if there exists a homeomorphism h between the two spaces from x to y which makes the diagram commute. So from x to x we have one self map, from y to y we have the other self map, from x to y we have homeomorphism h, and we need H composition F is G composition H. So if this holds and there exists such a homeomorphism between the two spaces, we say the two dynamical systems are topologically conjugate to each other. And just to mark कि H वो homeomorphism है, we write H above this sign. Okay. Then हमने बहुत important 3 important results की बात की थी जिन्हें हम अपनी टोपोलॉजिकल डायनामिकल प्रॉपर्टीज बोल सकते हैं. ठीक है, तो फर्स्ट ऑफ ऑल हमने 3 रिजल्ट्स की बात की थी. पहला रिजल्ट था कि इफ वी हैव 2 डायनामिकल सिस्टम्स XF YG topologically conjugate to each other, then XFN and YGN, these two dynamical systems are also topologically conjugate, and the homeomorphism which makes so is the same H only. Okay. Second बहुत important result हमने किया था कि अगर XF और YG दो dynamical systems हैं which are topologically conjugate to each other, then X will be a fixed point of F if and only if Hx is a fixed point of G on it. In other words, the cardinality of fixed F is equal to the cardinality of fixed G. So the number of fixed points remains preserved. And similarly, third में हमने किया था that X is a periodic point of, let me write PP for prime period n, if and only if Hx is a periodic point of G of prime period n. So here also that means the cardinality of the periodic points is preserved. All right. Now basically we'll have a look at some important examples क्योंकि मतलब जो इन 3 रिजल्ट्स को जो अभी हमने जस्ट पढ़े उनको यूज़ करेंगे हम. ठीक है, जिसमें तो ओके नाउ ये बात आप समझ सकते हैं कि अगर 2 डायनामिकल सिस्टम्स आपस में टोपोलॉजिकली कॉन्जुगेट हैं तो उन दोनों के फिक्स पॉइंट, उन दोनों के पीरियोडिक पॉइंट्स की कार्डिनलिटी सेम होगी. So this actually can be used to disprove, not to prove but to disprove, कि अगर मुझे पता है कि 2 डायनामिकल सिस्टम्स के अंदर फिक्स पॉइंट are not equal, or periodic points are not coming out to be equal. So that will ultimately imply the two dynamical systems are not topologically conjugate. Got this point? Okay, so let's have a look at some examples. So the very first example that I have is we have the dynamical system RF. This is the first dynamical system where F is a self map from R to R, f of x equal to 2x. And we have the second dynamical system RG, where G is a self map from R to R such that G of x equal to, so एक map है dilation map and the other map is a translation map. And here we will see that these two are not topologically conjugate. The reason is the number of fixed points. So you can easily check कि जो fix f है, so that is only 0, so the cardinality is 1. But here जैसे कि मैंने आपको पहले भी बताया था, ट्रांसलेशन के फिक्स पॉइंट्स होते ही नहीं, ठीक है, you can check. So cardinality is 0. So since fix f की cardinality is not fix g की cardinality, so the two RF and RG they are not topologically conjugate. Similarly, with these, if I take another RH, where H is a map from R to R such that H of x is x squared. So if you remember, इसका fix H 0 1 आता है. So the cardinality of fix H is 2. So क्योंकि सबकी कार्डिनलिटीज डिफरेंट आ रही हैं फिक्स पॉइंट्स की, सो वी कैन ईजिली कंक्लूड कि आर एफ नॉट टोपोलॉजिकली कॉन्जुगेट, मतलब टेकिंग टू एट अ टाइम, आई एम राइटिंग ऑल दीज एट सेम टाइम, इनमें से कोई भी एक दूसरे के टोपोलॉजिकली कॉन्जुगेट नहीं होगा. ओके, नाउ लेट्स टेक वन मोर एग्जाम्पल which is close 0 1. This is the dynamical system where f is close 0 1 to close 0 1, f of x equal to 1 minus x. We discussed this in previous lecture. And the second dynamical system is again close 0 1 close 0 1 g, where g is a self map from x to x such that this g of x is x by 2. Okay, so let's see, you know, इसके fixed points क्या होते हैं? So if you will put it, it will come out to be half. और इसके fixed point क्या होंगे? So it will be just 0. So cardinality और fixed point तो same आ रही है, so उसको तो हम use नहीं कर सकते. Now let's have a look at the periodic points. So if you remember, इसके periodic points were close 0 1 और इसके periodic points we need to check. So if I have a look at g square x, so it is g composition g of x, so it will be x over 2 square. So आप देख सकते हो कि if I will have a look at its periodic points, so it will be again 0 only. So 0 will be a periodic point of G of prime period 1. Alright. So what I am getting is the cardinality of periodic points of F is not equal to the cardinality of periodic point of G, means the two dynamical systems are not topologically conjugate. Right? Now, we have third example, and that is R okay, are these two. Let me not write this thing. Let me write topologically क्या आप इससे कोई सेल्फ मैप ला सकते हैं सच दैट ये दोनों आपस में टोपोलॉजिकली कॉन्जुगेट हो जाए, मतलब एफ और जी कोई भी मान लीजिए सेल्फ मैप है, कैसा हो सकता है कि दोनों आपस में टोपोलॉजिकली कॉन्जुगेट हो जाएं? थिंक फॉर 2 minutes. ओके, नाउ देखो, द रीजन इज they both cannot be topologically conjugate because we need a homeomorphism between the two spaces. याद करो, when I define topological conjugacy, मैंने बोला था एक homeomorphism exist करना चाहिए from x to y. Now the question is, does there exist a homeomorphism between these two spaces? And the answer is no. Okay, let me explain why is it so. क्योंकि अगर मैं मान लेती हूँ, let us suppose एक होमियोमॉर्फिज्म एग्जिस्ट करता है, ठीक है, देन एक रिजल्ट होता है that if I restrict it to A, which is some subset of X, if H from X to Y is a homeomorphism, then if I restrict it to A, which is some subset of X, then this map from A to F is again a homeomorphism. ठीक है, सो अगर मैं इसे रिस्ट्रिक्ट कर दूं और इसे हम बोलते हैं, लाइक आई कॉल इट पंक्चर टेक्निक. So what we do is we pick out a point from here. हम एक पॉइंट, लेट्स से मैं हाफ यहाँ से रिमूव कर देती हूँ, तो दिस H star from this to S1 minus F of half, this is a homeomorphism, right? Right. अब इसमें गड़बड़ क्या हुई? देखो, this is closed 0 1 में से I have taken out a point half. Okay, can you tell me that whether it is connected or disconnected? You will say it is disconnected. Agree with me? Now, what about this S1 minus F of half? Okay. अब देखो, ये पॉइंट जहां भी लाई करता हो, मुझे इससे फर्क नहीं पड़ता, बट it will lie on somewhere on this circle only, right? Say it lies here. It will lie somewhere on the circle only. So if I remove this point, I can still look at this point, look at it as a wire like this. मतलब एक पॉइंट हटा दिया और खोल दो, सोचो, तो अगेन इट इज समवट लाइक, मतलब इट इज कनेक्टेड. पर हमें क्या मालूम है, connectedness is a topological property. लेकिन हमें क्या मालूम है कि connectedness एक topological property है, means it should be preserved under homeomorphism. But what we are getting over here is, we are getting a homeomorphism in which one space is disconnected and other is connected, which is a contradiction. So because of a wrong assumption, so the closed interval 0 1 is not homeomorphic to S1. So this means the two spaces can never be homeomorphic, so they can never be topologically conjugate to each other. Okay, so we finally have that closed 0 1 not topologically conjugate to S1. Okay, the two dynamical systems are not topologically conjugate. Now let's have a look at one more example. So consider R with FA and R with FB, where FA is a self-continuous map, translation by A, and FB is a self-continuous map, translation by B, and we will prove that the two dynamical systems are topologically conjugate to each other. All right, so for that basically we need a homeomorphism from from one space to other space, and that homeomorphism is the map from R to R, where it is basically a dilation map where h of x is bx by a. Now we will show that first of all this is a homeomorphism. Okay, why? You can clearly check it is bijective, continuous, and its inverse is also continuous. What will be its inverse? So it is a map given by this. All right. Now we will prove that H composition FA is FB composition H. Okay, so let us have a look. What is H composition FAX? So it is H x plus A. What is H of x plus A? Just multiply it by B by A. So we have Bx over A plus B. What is FB composition H of x? It is FB Bx by A. Just translate it by B. And what we are getting is they both are coming out to be equal. So we are done proving that they both are equal actually. Okay, बस यही हमें prove करना था. So hence we get that RFA is topologically conjugate to RFB. यानी कि जो two हमने translations लिए थी they are topologically conjugate to each other. Now we'll have a look at last example, which is somewhat important in intuitional sense. So we have one we have a tent map, and the other one we have a logistic map. So it is a map from close 01 to close 01 given by 2x, 2 minus 2x, x in closed 0 half, x in closed half 1, and the logistic map, a map from again a self-continuous map where f of x equal to 4x into 1 minus x. So the first map is continuous by pasting lemma. The second map is continuous being polynomial. So what do we need to justify? हमें basically दिखाना है कि the two dynamical systems, this closed 01 with the tent map, this is topologically conjugate to close 01 with the logistic map. So हमें इसके लिए एक homeomorphism H ढूंढना होगा. So let us have a look at that homeomorphism H. Alright. So consider H a homeomorphism. We will prove it why it is a homeomorphism given by sine square pi x by 2. Okay, this is the homeomorphism. First of all, we will justify. So सबसे पहले हम देखते हैं why it is 1 1. So if I have a look at h dash x, it is 2 sine pi x by 2 into cos pi x by 2, right? So which is nothing but the formula of sine 2 theta. So it is sine pi x, right? Now if I pick x in close 01, my pi x will be in 0 pi. And as we all know, the graph of sine, it is positive in this interval. Open 0 pi pe sine is positive. So that means this is strictly greater than 0. And if my h dash x is strictly greater than 0, implies h is strictly increasing function on close 0 1. और एक strictly increasing function 1 1 होता है. So we have justified that h is 1 1. Now we need to show that h is onto. So note that h of 0 is 0 and h of pi, not pi, h of 1 is again 0. Here let me write the map for you. It is sine square pi x by 2. Okay. So by, क्योंकि 0 पे ये 0 वैल्यू ले रहा है और 1 पे it is taking the value sine 90 sine square pi by 2, which is 1. So by IMVT, intermediate value theorem, H attains all values lying between 0 and 1, implying H is onto. तो हमने H को 1 प्रूव कर दिया, H को onto प्रूव कर दिया. कंटिन्यूस क्यों होगा? साइन एक्स कंटिन्यूस है एंड कंपोजिशन ऑफ two continuous functions is continuous. ठीक है. So basically अगर okay, so हम इसे देख सकते हैं as composition if I take one map to be sin square x which is continuous, and if I take the second map to be pi x by 2, then what is this map? So it is h1 h2 of x is pi x by 2, and here, okay, so one thing I can do is, because if I write it like this, it is sin x square. Okay, fine. I think it will be fine. So this is sin pi x by 2. X will get replaced by pi x by 2 whole square. So this is sin square pi x by 2. So it is basically composition of two continuous functions. Now, why it is a homeomorphism? So we observe that H is a bijective continuous function from a compact space close 0 1 to Hausdorff space close 0 1. You know na, every subspace of a Hausdorff space is again Hausdorff, and close 0 1 being closed and bounded is compact. is क्योंकि H एक bijective continuous map है from a compact space to Hausdorff space, so this implies H is a homeomorphism. तो इससे हमें पता चलता है कि H एक homeomorphism है. Okay. Now, what else do I need to justify? I need to show कि तो एक पार्ट हुआ H की मुझे होम्योमॉर्फिज्म मिल रहा है फ्रॉम माय स्पेस क्लोज 01 टू क्लोज 01, जिस पे एक पे आई हैव द टेंट मैप, ठीक है, एंड अदर पे आई हैव लॉजिस्टिक मैप. नाउ वी नीड टू हैव लुक, तो हमें दिखाना होगा दिस मैप मैंने T से डिनोट किया था, राइट, एंड इसे हमने F से डिनोट किया था. तो हमें दिखाना होगा कि H कॉम्पोजिशन T इज F कॉम्पोजिशन F कॉम्पोजिशन H. Okay, so now let us pick X in close 0 half. Then what is H composition T of X? So Tx was defined to be 2x, right? Now what is H? Sin square pi x by 2. So I get sin square pi x. All right. Now, okay. अब मुझे यहाँ पे ढूंढना है व्हाट इज F कॉम्पोजिशन. नहीं, पहले हम फर्स्ट को ही कंप्यूट करते हैं, ठीक है. अब हम लेते हैं इफ X इज इन क्लोज्ड हाफ कॉमा 1. ओके, सो अगेन H कॉम्पोजिशन T ऑफ X, हियर मैंने डिफाइन किया था 2 - 2x इफ आई एम नॉट रॉन्ग. it was defined to be, yes, 2 minus 2x. Okay, which is again sine square pi x by 2. So it will become sine square pi minus pi x. You can check. So it is nothing but sine of pi minus pi x whole square. Okay, so it is sine 180 minus something, sine pi x. So this is sine square pi x. Okay, so this h composition tx, I am getting it to be simply sine square pi x. Okay, now let's have a look. What is the other? h composition t देख लिया, हमें f composition h देखना है. ठीक है. So again, if x is in, अच्छा इसे हमें डिवाइड करने की जरूरत नहीं है, उसे हमें इसलिए करना पड़ा क्योंकि t was defined distinctly दोनों इंटरवल्स पे. यहाँ पे तो हमें जरूरत नहीं पड़ेगी, we can directly compute. So if x, again pick any element. So what is f composition h of x? So the way we have defined it is sine square pi x by 2. And f was defined as 4x into 1 minus x. So this is sin square theta plus cos square theta is 1, and this is this whole square, which is 2 sine 2 theta, and which is, so we are getting the two things. One was h composition t, other was f composition h to be equal. अब देखो, जब मैंने एग्जाम्पल स्टार्ट किया था, मैंने बताया था कि कुछ इंट्यूशन सेंस में आपस में रिलेटेड होंगे. सो आई बी टेलिंग यू दी मैप्स ऑफ दीज टू. ओके, और फिर आपको थोड़ा सा देखना होगा. दिस इज योर होमवर्क. सो वी हैव टेंट मैप and logistic map. I'll sketch both for you. Okay, so this both the maps are from 01 to 01. Okay, तो पहला जो होगा, you can see it is defined linearly. 0 पे it will take 0, half पे it will reach 1, and then again 1 पे it will reach 0. This is the tent maps graph, and here okay, so here it will be cutting this axis at 0 1. It will be a graph inverted, and having vertex at half. It will take value 1 at half. So आपको देखना है एज आई हैव टोल्ड, मतलब मैं ऑलरेडी प्रूव कर चुके हैं हम यहाँ पे कि ये जो दो डायनामिकल सिस्टम्स हैं, क्लोज 01 विद टी एंड क्लोज 01 विद एफ, ये दोनों टोपोलॉजिकली कॉन्जुगेट हैं. एच साइन स्क्वायर बाय x by 2 is that होम्योमॉर्फिज्म which is making them both of them टोपोलॉजिकली कॉन्जुगेट. तो आपको बस देखना है कि ऐसी क्या क्वालिटेटिव प्रॉपर्टीज हैं जो इन दोनों में सिमिलर है. Okay, so here we end this lecture. Hope you liked it.